We're going to approximate the area under the graph of f of x equals x squared. We're going to use 4 subintervals and use 8 subintervals. And we want to choose the number u to be the left endpoint of each subinterval. If you watched the previous video, we did both. We used left endpoints and we used right endpoints. So I suggest you watch that video, because what I'd like you to do is after you watch this video is try the same thing I did on the video but use the right endpoints like we did in the previous video. The previous video was approximating the area under a line, a linear function. So basically we have y equals x squared, or f of x equals x squared. Those of y'all that know me by now know I can't draw. So this is the best I can do. You also notice this is not really proportional because my units go here 1 to 5 on the axis here. And then on the y, we're going basically to 25 on there. But you get the same idea. So basically we want to find the area under this curve by taking small rectangles under the curve and taking the area of the rectangle, because we know the area of the rectangle is base times height. Now, since we're doing 4 intervals, we have, this is our A and B. To find the units of each of these, they have to be equal units. We're going to take B minus A over the number of intervals. In our case, we have 5 minus 1 over 4. So that means we're going to have 4 subintervals. So we have 1, 2, 3, and 4. And they're each equal length of 1. So basically it makes it easy. We need the length here, which we have. All of these are supposed to be 1. They don't look like it, but they're all supposed to be 1. And all we have to do is find the height of these. And in case, in this one here. So we're taking the height of, we're using left endpoints. Because we can't use all 5, because then we'd have too many rectangles. So we're going to approximate the area. And the area is going to be, it's basically base times height. Well, our base is 1, but I'm going to do the height first. So it's f of 1 times 1 plus f of 2 times 1. Again, this is your height, this is your base. Height, base. Plus f of 3 times 1 plus f of 4 times 1. And recall our equation is y equals x squared. Let me write f of x here. So we have f of x equals x squared. So plug in 1. 1 squared is 1, so we have 1 times 1 plus 2 squared, you're plugging that in, is 4 times 1 plus, plug that in, and that's going to be 9 times 1 plus 16 times 1. So basically you just have 1 plus 4 plus 9 plus 16, and that equals 30 units. So if I go back and look at this, I found the length here to be 1, the length here to be 4, the length here to be 9, and the length here to be 16. So all I was doing is finding the area of each of these rectangles and adding them up, and that approximates the area. Okay, this one we're going to have 8 subintervals. So I had to find out what my units will actually be. That's B minus A over the number of intervals I want. So that's 5 minus 1 over 8, which is 4 over 8, which is 1/2. So each of these units here are 1/2. And I have to do this 8 times because I've got 8 triangles. And all I'm doing is base times height. And in this case, really what we're doing is height times base. And we just need to find, all we need to find is these links in here. Because we already know our other, and that's our F. So recall, all of these units in here are 1/2. That's from here. So I'm going to go to the next page and do that. So for the area, we have, it's approximately again, F of 1 times 1/2 plus F of 1.5. So that's 3/2 times 1 plus F of 2 times 1/2. This is 1/2. My units are 1/2. I'm still on the first problem. All right. Plus F of 2.5 times 1/2. I got 4 more to go. Plus F of 3 times 1/2 plus F of 3.5 times 1/2 plus F of 4 times 1/2 plus F of 5, 4.5. So that's going to be 4.5 times 1/2. And when you figure all that out, it's all going to equal 35.5. So which one do you think is a better approximation? When we subdivide it in 8 subintervals or 4? You think 35.5 is a better approximation? I do too, because it's just looking at it. What happened? All right, just looking at it here, we got closer and closer to this curve, and this was a simple curve, not like some polynomials. This is a basic simple curve, and we got closer and closer to it, whereas the first one we did, we have a lot of white space in here. See this white space in this area here. We left out all of this when we were approximating the curve. All right, so what I'd like you to do, if you could, is do the same thing, but instead of left, try right, like we did on the first video. And that's all.